Hi, today we're going to begin the material for the next exam, and we're going to start off with population geography. Population is really just the total balance between births and deaths. So we really just need to look at those two different forces. How many people are being born, how many people are dying. And that essentially is what population is. It's really just a balance between births and deaths. The one thing, however, that does complicate the matter is migration, because many times populations will increase and decrease by migration alone, and it really has nothing to do with how many people are being born or how many people are dying. So because migration has such an impact on population, we're actually going to devote a separate lecture to migration. If we look at the global population distribution, we can see on the map that it is not evenly distributed. It is definitely unevenly distributed. And for the most part, we can break it up into those areas that are habitable versus uninhabitable. In other words, can people live there or not live there? And you can see on the map that those places that have extreme conditions tend to have lower populations. We can also look at whether or not a place is arable or non-arable. In other words, can you grow things there? When people were shifting from nomadic populations or semi-nomadic populations to more stable populations in towns and cities, they needed to have a stable food source. So most cities did not grow and expand unless they had arable land available. In some places there are alternative things that have attracted people to a particular area. Is there an alternative way to make a living? For instance, is there a resource cluster there? Can there be mining, for instance? So in places where there are high population densities, but the land is not arable, there's usually something else beneficial to that particular land in order to attract people. We also see differences in density. And density is essentially how many people per square mile or per square kilometer. We're going to talk about that on the next slide. And there are also implications to having certain population densities or higher growth rates or lower growth rates, and we're going to get to those in a minute. Before we do, there's some terminology that I want you to be familiar with. And these are terms that you may encounter while working on your projects. And the first one is crude birth rates and crude death rates. These are just raw birth and death rates. So I gave you an equation for birth rates, which is the number of births in a year. So that's not divided by the year. It's just the number of births in a year divided by the total population. And that total population is usually an average population for the year, or it is mid-year population. So that's just a crude, non-adjusted birth rate. A death rate would be the same thing, the number of deaths in a year over the population. So in some cases, you want to know what the actual raw data are when it comes to birth rates and death rates. In other cases, you might be more interested in how fast is the population growing, or the growth rate. And you don't need to know the equation for this necessarily, but I do want you to know that it is usually expressed in a percentage from 0% to 4%. And the higher the number, the higher the percentage, the faster the population is growing. So you could have a population that has a relatively low population number, but is growing very quickly, and that could be a concern. Or you might be concerned with how dense the population is. And density is typically expressed in the number of people per square mile or number of people per square kilometer. You might see it with either measurement. Again, this might be useful if you have an area that has a lot of people, but it's a very small landmass, or very small territory. So you have high densities, which could have their own implications. Now, another way of looking at population is with population pyramids. And I put here problems with an aging population or vice versa. We're going to get to that question in a minute as I explain what population pyramids are. I think it'll be useful to show you some pictures of population pyramids. These are 3 different population pyramids. And the way they are drawn is along the bottom, you have percent population, and sometimes you might see that in thousands or millions of people, but typically it's percent of population. Then on the right-hand side, you have the number of female. On the left-hand side, you have the number of male. And then you can see that there are age brackets, 0 to 4, 5 to 9, 10 to 14, etc. So you would draw one by saying, okay, if we look at Kenya, how many females are there between the ages of 0 and 4? In this case, there are approximately 9. So you draw a dot at 9. How many males are there between 0 and 4? Well, there's about 9.7, 9.8. Draw a dot there. How many females are between 5 and 9? A little less than 8. Draw a dot there. How many males between 5 to 9? Well, it's approximately 7. Draw a dot there. And you go all the way up the age brackets, and then you connect the dots. And when you connect the dots, you have a shape. And that shape alone will tell you a lot about the population pattern of that particular country. If we look at Kenya, for instance, you have a wide base and you have a very narrow top. That means that you have a disproportionate share of people in younger age brackets. So this is a country that is experiencing rapid growth. Next to that, you have the United States. Now keep in mind that this particular graphic is a little older. It's about almost 20 years old. So where you see that bulge for the United States, that's moved up a little bit now. And that bulge represents baby boomers. So now we're almost approaching a point where you have an inverted pyramid, where you have more people at the top than you do at the bottom. And each one of those has its own implications. So for instance, if we look at a country that has a very wide bottom, that means you have a lot of people being born, you have a lot of people dying. So you have high fertility rates and you have high death rates. And you have that disproportionate share of younger people. What would that mean as far as implications for that particular country? Well, that would mean most likely that for one thing, you're going to have a strain on a lot of resources. Because you're going to have a lot of people that are not of working age, that are not necessarily contributing economically to the economy, yet they're using resources. So they're giving back. They're not giving back, rather, but they're taking. So there's going to be a huge strain on resources. It's not necessarily any better to have an inverted pyramid as well. Because here, too, we're going to have people at the top now that are using resources. Now, it's not quite the same as children, but we do have that particular same type of scenario where there could possibly be a strain on resources, especially when it comes to things like healthcare or things like Social Security. So in the United States, for instance, we are now facing that issue with Social Security because people are living longer and longer and longer. And initially, we may not have envisioned people living well into their 80s and 90s and even past 100, where people are retiring and then starting entirely new careers. So the question always becomes, how long will that system last? And there are all different theories. Some say if you're not already 40, money's going to run out. Other people say there's enough money for generations and generations and generations. Everyone has their own theory on that based on their own economic models. But it is a concern nonetheless. Are there enough people at the bottom to support those that are at the top? We can see an even extreme case here in Japan, where they are probably going to reach that completely inverted pyramid much faster than we are. And you can see their 2050 projection, rather, shows that inverted pyramid. And they have even gotten to the point where they are paying people to have children, they have financial incentives. So typically when we talk of population, we talk about overpopulation and population explosion and population boom, and we need to slow down population. But there's a difference when we're talking about regional population issues. Globally, are there a lot of people? Sure. Do we need to do something about it? That's going to be a discussion question. But at a regional level, we can see many, many places that are growing at a much, much, much faster rate than the global average. But we also have places that are growing at a much, much slower pace that are at a barely replacement level for population, if not a negative population growth rate. So Japan is one, Italy is another one that is actually paying people to have children. Now, one concept that I want to talk about that has to do with population growth is a theory that was invented by a person named Malthus. Some of you may have heard of him. And he basically believed that population grows at a geometric rate, or an exponential rate, or logarithmically. So it's not just 1, 2, 3, 4, but it's tenfold with each successive increase, while food resources increase at a linear rate, or arithmetically. So you can see, looking at this map, that food supply is the blue line, that's growing one way. Population is the red line, that's growing another way. So what he's basically saying is that if you have a population that's growing much faster than food resources, then at some point in time, you're going to run out of food. And then that is inevitable. And he believes the only reason we haven't done this yet is because of what he calls Malthusian checks. Now this sounds a little morbid, but Malthusian checks are essentially events, natural or otherwise, that kill large numbers of people. So it could be a famine, it could be a natural disaster, it could be a war. He believes those things take place to keep the population in check. However, he says even with those checks, at some pace, the population, or at some point, the population is going to outpace even the checks, and that we will run out of food. Now, like many things that we talk about, there's typically an opposing side, and the primary criticism to Malthus is that this theory was devised long before some of the technology that we have in food production today and agriculture. That this was before agricultural revolutions, where we have advancements in production, and that we will meet the need should it come, and that perhaps it has more to do with food allocation rather than the sheer number of things we're growing, and that we could modify food, and we could continue to, we already do this, but we could continue to genetically modify, grow things in water, grow things in space. I mean, there are all sorts of things that could happen. Of course, this gets very scary for some people as well when we talk about genetically modified food, because for some it could be somewhat of a slippery slope. And are we going to modify plants and animals to the point that they turn on us and attack us and all of that sort of stuff? But that is the main counter to Malthus. That the technology at the time, this was in the 1800s when he put this theory together, the technology at the time is not the technology that we have now. It's not the technology we're going to have 50 or 100 years from now. So that's the main criticism. But there's still many people that believe in this theory, and they are called Neo-Malthusians. So it's still a very popular theory when it comes to population. We're going to stop here, and we're going to pick up with demographic cycles in part 2.